So let's jump in chapter 7. Here we go. I just go to the home menu and I'm going to open up a new file here, or browse for a new file here. Sorry, browse for a new template to start with. Yeah, all we start with is this one here, this in the assembly um, a .iam file is what we will use. I think I mentioned yesterday, I haven't really used mold design much. I don't know how long it's been a feature here. Weldments have been around a long time. We will use them next week. And so chapter 8 will cover IPN. These are what I call kind of the four, just these four groups of kind of main file types, I guess. So this is my new one, a standard assembly file. Looks like Lego bricks. Open it up. Looks pretty much exactly the same. It doesn't, you really can't tell much difference. The ribbon menu is slightly different. That's about it, but it looks like a part file model space. In fact, it has a lot of the same, has a lot of the same browser tree. I have the same origin. So I'll already have an existing origin point in an assembly file. And so what it's ready for is for you to place parts that you've created into here so we can join them together. That's the main feature of an assembly file is just to join individual parts together, right? So what do I have? An assembly tab, which looks a little bit different. Yeah, I guess that's a new tab that isn't on a part file. The assembly tab, assemble tab. Yeah. Design, yeah. So we have some design. Here's where we could actually design a spur gear and some belts and some bearings, disc cam. All right. So we have some preloaded design software here, or at least a palette. What do we got here? Kind of our normal 3D model, because I can actually draw a part from even in here too. So I can be in an assembly and draw a part. So I have a lot of the same kind of part commands along with sketch and annotate. I can still do annotate like I could in a part. I can annotate here as well. Um, which is essentially using your drafting skills to annotate on your parts right here. I know they're not on a drawing, but they'd be kind of with the part file. And so, I don't know, maybe some reasons why I would annotate on a model is because I can just share a model with somebody that has all the annotations, maybe some machine work that's going to be done. I don't, so I could forego maybe sending someone a drawing and I could send them just a model with all of the annotations within the model. I can do that on a part too, but let's see here. I don't think we'll use any inspections for a while here. Yeah, I feel like some of these are very similar here. My view tab I might have to use a little bit here. All right, we have some different programs we can run on our assemblies. Yeah, we'll scratch the surface here for this today. Just on the assemble tab is where I need to start with an assembly. Um, and so working left to right here, generally with assembly, you're going to place parts into it. So the first command is to place here on this far left. Place does have a few options of how you can place stuff. Place, I just the normal place just means it's going to browser search for you to find a part to place in here. There is a content center that's preloaded that comes with Inventor. And you can download other items for content centers, but I think of them as like library parts, like fasteners, plumbing fittings. So I haven't explored too much of what the default content center is in here, but it would have downloaded a fair amount of material with this program. Maybe not like everything, but some general use stuff. Content center. Yeah, I'm in an assembly file. Yeah, so I'm just a standard assembly, not a weldment, not a mold design, just a standard assembly. Yeah, and I'm gonna place some parts. So the first thing is just to place some parts in here. Um, so if I just say place, just regular place, it should open up a Waddle browser like this. You should have to drive down to where your folder is, right? Looks like mine's pretty well on my. I'm in lab. This is week 3 for me. So this is where I stored all my parts that we did yesterday. I'll use the ones that I did in class here. So just a little side note here, within file structure, you have your like assembly files look like their imagery, look like part files. You can change your icon. It's one way to verify them anyways by their icon if there's assembly or a part. I'll show you how to manage that better maybe. Well, on my pipe support or on the V twin. Generally, when I build an assembly, when I'm working on a job, I may have a folder with the job number on it. I think I mentioned this. And then within that job folder, I might have a few subfolders, which might be parts, assemblies, and drawings. Sometimes I don't put the drawing in its own folder, but sometimes I put my parts and assemblies in their own folder, and that just can help me not have such a huge folder to manage. Can easily find my parts, can easily find my assembly. My drawing might be on that initial first folder when I go in because it's the master. But anyway, I feel like you have to get pretty good at organizing files because then you have to also worry about when if you go to move those files, you're going to complicate things because of the communication between parts, assemblies, and drawings. If you start moving stuff around within your file structure, you usually have to go re-find it. You'll get a prompt usually that you've got an error, something is missing, cannot find where that file used to be. So if you have a drawing with a part that you move the file, it's going to give you some errors. You're going to have to relocate it and realign it. That's going to be a good deal with here if you're moving stuff around. So pre-planning your folder structure helps prevent some of that, some of those problems moving files around. But we should have some of that blow up on us. I'll try to make some of that happen so we can work through how to fix it. But yeah. So let's see. So my parts are just I right now in my file structure, my parts and assemblies are just kind of thrown in the same mix here. So I don't have too many to manage, so they're pretty easy to find. But I really need chapter 6, 1 through 5. If you named them like the book said, I think you'd have a piston case, wrist pin, crankshaft, and a connection rod. Those would be your 5 parts. I'm just going to open them all up. So mine are just part 1. Here's part 1. Okay, open it. I'll just place it. So when you open it, it actually, you have like a grip of it. So once I've chosen a file, it just wants you to place it in the, place it in model space here somewhere. I can just left click and it places it. Its default is just to keep placing this part. So once you have this part, it doesn't know if you need, 10 of these things or one of these things. We just need one. So I can just hit escape. And then that one part is placed. Mine are coming in with all the, yours might not be coming in. Mine are coming in with all the planes turned on. That's just probably because of the way I saved my part when I stored it last. I had those turned on. That's no problem. I'll turn them off. Um, let's see here. I'm going to place all my 5 parts in here. So I'm going to go back to the same place. Let's grab my part number 2. That is this one in class. I did it right here yesterday. So I'll open it up. And I don't know, maybe yours do come on with the planes. I can't remember if I stored them all with the planes on it, but I only need one of those as well. Yeah, just one of those. I think I just need one of everything. So I'm going to place part number 3 in here. Part 3 in class. This one, right? Open. Yeah, see that one. I must have stored these with the planes on because this one wasn't stored with the planes on. Okay, let's see here. What's part 4? Place that in here. Part 4 in class. Yes, open it. Yep, we just need one of these. I'll place it. And the last thing is a connection rod should be place it in class. Place open. So I have all those. My default on my assembly is just to show this is the view that it has. On the view tab up here, view tab, maybe center of the tabs right there, view. I like mine to be shaded with edges. I can see the edges a little bit cleaner. I don't know, just shaded without edges. The surfaces seem to blend together a little bit. Not impossible to pick an edge, but I really prefer this shaded with edges to kind of be my default view for me. I think in the options tab, I can go and set that like this options tab, which is in the file and my options, like my main driver of options for this thing. I think I can peruse through here and find where to set my assembly view up as like shaded with edges or something. I've got to find that. I don't know where it is right off the bat. It's not the end of the world. I have to come over here and pick one, but it's nice if it just is loaded how you would like how whatever you prefer. There's a ton of different ones, right? Yeah, there are. Kind of like CAD. Definitely very similar to CAD. I feel like I use shaded with edges the most, though. All right, so we have 5 parts. I'm like I said, I'm going to turn these off. So what you have is these are all your individual parts. You can get through them. You can open them up if you double click on this thing, I think, or if you just like right click and hit open right here, open, that'll go to the parts. That'll just automatically open it for me. But I think I can just double click it too. Nope, double clicking will go into an edit mode. Pause on that. That's good to know. But if you see that one part stays normal and the other ones all go shaded, you're actually into an edit mode on that part, which means you can kind of treat it as a part and you could do sketches on it and you can do a bunch of stuff. It will kind of be driven here in the assembly. And so, anyway, how I know that that happened is just that those parts go shaded when I double clicked on it. And I have this like little return button up here, which means I'm going to return to normal mode here, there. So just watch for that. If you double click on a part, you're going to go into a different ribbon menu. You actually have a you've actually activated a little bit different, more of like a modification on that part. So I'm not going to do that. I'm going to do my normal, just right click, open that. I actually need to open this one though. Open it. This is just for me. I'm going to turn off these planes right now. So I'm going to come in here, turn off my planes, and turn the visibility off. This will affect it in the assembly if you can see this right here because they are communicating the two of them together. So what I do on the part file is going to be affected here in the assembly file. So I'm going to open this one up too. If I shade, let me see here. If I turn this off, like here, okay, so once I've placed all these parts, here's my model browser starting to build out with the parts. If you expand these parts individually, you'll kind of get into like what you can see in the sketch mode a little bit here. I don't think I can get, I think I can get to the original. I thought I could get to the original. But if I turn these off, let me do this. If I turn these planes off within the assembly, and I open this up, it may override how I've saved this. I think it maybe does. So I feel like I can turn them off either in the assembly, drive down to their origin off their planes, or open up the part, do any manipulation. Generally, when I modify a part, I usually go to the part file and do my modifications and then let it update my assembly. But we'll do some different things here. So what we have now that we have my 5 parts, how I want them, they all just move freely in this model space, right? They like I can grab them with this is just left clicking them and grabbing them and move them. They are not. The idea here is we're going to put them together, and so we're gonna apply constraints. So your whole world of your parts and how they work together, we have to put constraints on them. Oh my gosh, the word of inventor is constraints for sure. Constrain your sketches. Then now we have to constrain our parts together. And so the other thing I want to say is sometimes when you're building stuff, when you drag and drop it in or just from placing it from the file, it's not always in the orientation you want it to be. So sometimes I need to spin these parts individually from one another. I use I don't know where on the ribbon menu this might be, but I use G on my keyboard. And it puts this little scope box around it. So I think all I did was if I just hit G, and then I select a part. It'll put a scope around that part. I can select the part first and then hit G, but it puts the scope around it. Now, if I left click here, I can actually rotate this thing in any orientation that I want. So I don't know if this is called out in the book specifically, but this is how I would orient my part. Roughly, like if this part over here needed to be rotated up like this before I assemble it, I can do that. Just like push G on your keyboard, pick a part, and then rotate it how you need it to be. So that's really handy to me. Obviously, my 3D mouse helps me orbit around this thing as well. But let's do so the nature of an assembly though is that one part has to kind of be fixed. Like you're trying to constrain them together. So if one part isn't kind of locked down or what we call is like grounded in model space, then it's hard to constrain something because they can both move. Right now, everything can move. So the idea is usually with an assembly, there might be one part that's kind of your foundational part that you're going to just kind of ground and root is what I use. But you're just going to ground it essentially so that it doesn't move, and the other parts can then be kind of constrained to it. So that's kind of the idea here. Sometimes you need to pick a foundational part to start the assembly from. And a lot of assemblies kind of have a natural part for that. In this case, the natural part that I can see is the crankcase. And this is because I know the end from the beginning. That makes a difference as well. But this is the crankcase, or the cylinder case, piston case. There we go. And it is going to be the one that I'm going to ground and then assemble the other parts to it. So to do that, a lot of different ways I can do it. But one way is identify for sure on the model browser which one that is. If I select it, here it is. It's this one right here, right? Here's my part. That's my foundational part. It doesn't matter which order they're in necessarily over here or which order you place them in the assembly, but I just like find it here. If you right click over here, it's a pretty big menu. I think on here there is a grounded right here, grounded. this is going to make sense to some people with Revit skills because if I hit ground here, it's kind of like this is and it's usually close to where I have the visibility turned on and off, which you can turn on and off the visibility of these parts. If you hit visibility here, your whole part will disappear, and it will go shaded over here on your browser tree. So it's easy to identify if something is turned off. But right below it here is grounded, and a little pin shows up. It always drives me crazy in Revit that really powerful little thumbtack pin can be super annoying if you don't know that something is pinned down and you're trying to move it and you can't find that and that little pin is such a little icon. But if that shows up on my model tree now that says that part is like pinned in place, I'm not going to do that exactly, but that is one way to do it. In the book, he just, I think, goes in and grounds it and pins it there. And really the reason why I'm not going to do that is because I just pinned it in no general like orientation. Like here's my front view. So if I pinned that part there, that's the orientation it's in, which is kind of sloppy. If I'm thinking about putting this on a drawing specifically, this isn't, my front view is going to come in naturally, even on an assembly. When I go to place assembly on my drawing, just like a part, it's going to be a base view of the assembly, and I'm going to be able to rotate it. But if I'm in some weird, wacky orientation, it doesn't make sense to a drawing view per se. So I don't just usually come in here and just ground one randomly. I actually do what is called a ground and root. And I don't think this is in the book. So I'm going to unground this. All it is a matter of like unchecking this thing, and then this thing can now move again. I didn't show you though, but like I said, I'm going to over explain this a bit. I know I'm going to bore some people, but I'm going to keep going. This thing I can't move now. When it's grounded, I can actually not move this thing, like click and grab it. And so I can if I just unground that again. Now this thing becomes totally movable. So what I prefer to do is what's called a ground and root. And so if I go back to my assembly tab and I just go down here, so placing, the component palette here is where we place, where we can create a new part as well from right here, create something. Free move, free rotate is kind of what I'm doing a little bit with that G button. I can't, I think so. I think you could actually select it. Maybe I'm right. Maybe you could select it up here, come over here, and now, oh yeah, yeah. So I forget where it is on the ribbon menu. I use G on the keyboard, but here is the same option. This free rotate helps you like orient your parts into what's going to help them be in their best orientation. Or G on the keyboard's the same thing. So uh, the relationships palette is where I'm going to do most of my work here in an assembly in order to like hook them together. That's what we call relationships. In an assembly, I have I have this little relationships file up here. So I have model states like I would in a part, and I think representations is in a part, maybe not. I think it is. And then relationships is new to an assembly because that is one that's going to house every time we click and hook stuff together, it's going to house it's like a constraint up here in a relationship. It's also going to house those relationships in the model tree with the parts that they're associated with. So it's kind of redundant, but relationships was really going to house every constraint that I apply in an assembly. So it's and you have to kind of keep track because you're going to apply constraints and sometimes you have to manage and move parts and you have to undo constraints sometimes. And this was really frustrating for me to learn uh, just how to apply constraints and what are the best constraints to apply. And it goes kind of into the same mode as like as building a part in that really I feel at first it's going to be sloppy and then you're going to get better just through practice and time and having to undo constraints and having to work on like, oh my gosh, it doesn't move the way I want it to, and some frustrations will help you iron this out. But there really is there's no right or wrong way to constrain. There's definitely just good, better, and best ways to allow the movement that you need something to have but not allow it to move in ways you don't want it to move. So I think it's a fairly deep study and each part is kind of unique. So pattern we can also do just kind of like with our we can do similar patterning with features and part patterning that we could do in a part, but as here we can use the whole part in an assembly and do a pattern. Okay, bill of materials is good. Bill of materials, that'll be necessary for us when we go to our sheet and bring up a table that has our parts itemized. Of course, we can change the appearance. This is what I want to show you here. This drop-down list is huge, I think. Yeah, there's a lot of different things here on this. This seems like a really small palette here, this productivity, but expandable, and it has a lot of stuff that I do use here. And so this is where I can add a part, I can add an assembly, but what it has, the only thing I really want to point out here is that it has this ground and root right here. So all it is does the grounding function, but what it roots it and it lines up all of the origin points and planes from the part to the origin points and planes in the assembly. So I like to ground and root my kind of my foundational parts in an assembly, and that way all of the planes are lined up and all of the axes are lined up the same. And so if I pick this ground and root, this may not work. I've had trouble with, oh, it does. Okay. If you pick that, this dialog box should show up. I hope it does. I hope it doesn't. My computer had some issues. Sometimes I don't know if you're having any issues with your dialog boxes at home, there could be some of your screen resolution issues that the pop-up blockers maybe. I don't know. I had to work on this one. I had to like I don't know what I did to fix it actually. I can't remember. It was really frustrating. That freaking dialog box would not open up. So hopefully everybody's pops up because I can't tell you I know exactly how to fix it. I also have additional problems because one of my screens goes to the projector and sometimes that fouls up my pop-ups a little bit. I don't know why, but I feel like I got it fixed because that is what it should pop up. And then it wants me to pick something to ground and root, which multiple things can be grounded and rooted. Everything could really be grounded and rooted other than it makes the assembly less movable. Parts don't move within themselves if they're ground and rooted. So I'm just going to ground and root the one part, the crankcase or this piston case, sorry, right here. This piston case. And I just hit apply, and this thing should move and fly around space. Now that is in the orientation of kind of how it was in its part file. And so it really it looks grounded over here on the model tree. It still has the same little pin that showed up, but it is rooted in the sense that if I like turn on its origin planes here, shift select these, and then I'll turn them on. So there's all of its origin planes. They should be matching the assembly origin planes here now. So all of my planes are kind of in alignment and my axes are all going the same way. And so technically, this is going to be how it would ground and root based on how I had drawn it in its, I think we drew it this way as the front view. And so now this thing to me is ready for like a base placement on a drawing. It's in its front view. Whether that front view is correct or not still doesn't matter to me too much because once I go to place that base view on a drawing, I can rotate it there to be the way I really want it oriented. But at least I'm not in some skewed angle to the main view cube like projection planes, right? So that's important to me as a drafter for sure. For somebody just regular modeling, they wouldn't really give a crap because they're not worried about what it looks like on a drawing. I am, and so I need to know that I'm, not just in some funky orientation in model space, that I really am ground and rooted to the view, to the origin planes and axes and center point. So that's what I've got here. And now that thing won't move either. So it is grounded, but it's rooted, ground and root. What good is grounding if it doesn't have any roots? Okay. Ground and root, and that's hidden here. It's definitely on this one will change whichever last you use from this list. That's pretty big list here. It'll be available to you here. So, like I say, I don't ground and root every part. I just want to ground and root that one. A little side note for those that maybe understand, but if I had actually built a bunch of parts together and then exported them as individual parts from a part file into an assembly, I could ground and root every one, and they would go to where they were built in a part file. So, and that's cool because it just is a quick way to assemble something that's all the parts have been built together. Bam, I ground and root them, done. I move on. My assembly is in display mode, ready for print. The problem is the constraints. If I need to animate it or if I need to check on some, how the thing is going to move together, I may have to undo some of those and reconstrain them. So that's just a little. Don't worry about that too much, but ground and rooting can be a fast way to assemble stuff if you've built it all together. These were all built individually, so they don't really have a relation. They don't really share a good relationship here. But I've ground and rooted them. I'm going to go ahead and turn off these planes. I was just showing you that they align with the master origin planes for the assembly, and so they are in alignment. Okay, so that's a little bonus stuff there. He goes into so he does ground that in the he just does a ground with his piston case. Let's see. I think he does kind of show how to orbit them and move them. Or does he start putting them together? I think he just puts the piston in the piston cylinder here, this bore here. So we're just going to assemble this. It actually is meant to slide in here. This is kind of just a piston case, and this thing is going to slide, and really on a piston it slides in and out of here. So if I go to constrain, so what we want to do is we want to constrain it. The difference between joint and constrain, I think, are about the same, actually. I mostly use constrain, and I don't use joint very often at all. In fact, I'd have to do some little bit of reading to see the difference between these two. They act very similar. Um, I will use constrain here. So constrain, I choose constrain. This little dialog box shows up, which is a small dialog box with a lot of power here. So really, I have what, like four different tabs here. The assembly tab is the one I use the most. I would say I use motion less here. I feel like an engineer when I'm looking at some of these others, but let's see here. Just a simple assembly tab here. Then the type of assembly I have is what? A mate. What is this? An angle one, a tangent, an insert, and a mirror or symmetrical, how I would constrain this. And then usually it has selections here. These are so really I choose the type of constraint that I'm going to apply. And then I choose, usually the selections are going to be like one part to the other part. So there's always at least two selections for most constraints. You're going to have like a selection on one part and match it to a selection on the other part. And then I can kind of reverse that. So like the solution here is kind of like whether, I guess they call it mate and flush. But I feel like when I get to that, it's like, do I want it that way or do I want it the reverse way? I feel like what they kind of do is reverse each other in some ways. So if it doesn't constrain how I thought it was going to be, sometimes if I just change the solution to the other one, it will be in the orientation that I may have been expecting. So let me show you here. I feel like we will use type and this mate type a lot. I think that's the only thing I'm going to use. I think I use one angular constraint here, but so here it is. There's a lot of different things of a mate constraint can be, but if I choose this mate, it's already like select one. So I'm going to say, well, I want to put this piston in this hole here. So now as you start to hover over, I'm just hovering, I'm not clicking. You get the surfaces and features and axes of this part as possible things to constrain. So this thing has a lot of different places to constrain. Like it has, I don't know, when I select this, the constraint that it's applying is that axis right down the middle. With the little drop-down menu, it shows the other constraints that are available in this part. It has a face constraint, which is kind of the outside surface. I guess this axis, is it going the other way? I can't tell. No. And then the inside face, a center point, I guess, on this face normal. So this is kind of a strange list to me. I didn't know exactly what I was going to get on this list, but these are just constraints that show up. And I could also just hover over this. This is me like selecting this surface as potential like a thing to constrain to something like this surface. I could choose this axis of this hole here that shows up. It kind of shines the edges of my feature, but then it shows this axis, and it even has a directional arrow on the axis if you look at it here. Uh, to switch that directional arrow, I don't always know if I can just hover. I don't think so. I think it kind of has this preloaded directional arrow that way. Um, so anyway, I was just trying to explore this. Here's a face here. I could choose this face. I could even choose these faces, this face. So every part, has a lot of surfaces and axes or axes. And I don't know, just it has a lot of different places you could click on here. Any place I left click is going to consider it as selection one. How the book says to do it and how I would do this is I want to actually take the center axis of this and really I don't feel like this axis that's showing up is necessarily like the X, Y, or Z axis. It's really just that this thing is a cylindrical part. And so, inventor knows that it has a center axis down it. So it's not necessarily thinking of it as like maybe its origin axis that was drawn by, although it does have that because I think I drew this thing with the center on the origin point within the part. So technically this axis is kind of one of the origin axis, but it's not always that way. It really just has this because it's a cylindrical part. The same as this. This isn't maybe the X or Y or Z axis at all. This is just a no, it's a cylindrical part. It has this axis. It's available to constrain. So I'm just going to say, oh, I want this one. I'm going to take this axis constraint, and now it automatically moves me to selection two, which means I need to go to the other part that I want to hook this to, which is this one over here. And this part over here has just as many surfaces and just as many features that could be a constrained uh, where I could constrain this to. I'm just going to hover within the bore here, and the axis shows up that I want to align the piston axis to this piston case axis. So if I select this, it just bounces over there and I get that click if I have my audio on. That's a good sign. If it doesn't click, it just means it actually is an unacceptable constraint and it won't even apply it. And sometimes you don't know that it won't accept it but you're not hearing that click. But the axis, I don't know, the axis, yes. This is axis to axis. I've only just left click both. I'm still kind of in the command. It needs me to do those two selections, and then if it works, they hook together. And then it also kind of changed my solution because it's like, oh, I recognize these are like cylindrical. And so now instead of being like those plate looking things, they're actually these like a shaft and donut, shaft and these like anyway, the imagery has changed here on my solution. Actually gives me three different solutions. Yeah, like mine is in the correct orientation. If you know, yeah, and you wouldn't know this unless you're looking at your book or whatever, but mine actually, just by pure kind of luck in some ways, when I chose both of mine, my piston is oriented correctly in here. If it wasn't, if I just click this other solution, it's kind of doing the opposite way. It will spin it spins my part, it spins my piston in there. Because it's like, oh, you didn't want to be that way. How about this way? So it's like another solution using the same geometry. Yeah, this one is what unidirected, so it goes both. I don't know. That was not going to be a really viable solution for me here, but this one is the way I need mine. And this just all this is going to do is these are going to be hooked together, and that just means these two bores, the bore of the piston, kind of the this axis of the piston and the axis of the piston case, are going to always be aligned. Um, an offset would be if I want them not to be aligned and I want the offset. I could type in a number here if if the two axes were not supposed to be aligned and they would be, but that would be a weird constraint because it would just misalign those, but they'd be able to rotate around each other. So it would be like it wouldn't really lock it down too good, but it would just be like they would be spaced off each other a little bit. I'm not saying you don't do that at times, but here we just need it to stay zero. And then if I just hit OK on this or apply, if I hit OK, it closes the dialog box. If I hit apply, it lets me go right back into, like if I hit apply, it's just like, okay, now what do you want to do after this? If you hit OK, it just closes this, which is no big deal. You can just reopen it. And so here's my two parts in, yeah, go ahead. Yours is not working. As I kind of stopped, sorry, missed recording that. So I just noticed that now. Back in here, guess what? I did a few constraints you didn't see, but they're in the book, so not too worried. But here I'm just exploring the ones that I applied. Here's the quarter-inch offset mate that I did there, kind of, and then here was my 0.7825, which rounded to 783 offset here. You can change these here. Like actually, if it wasn't right, this is you can edit these, right? If I just single select, it gives me access just to immediately do a dimensional change here on the constraint. These also redundantly show up in the parts that those constraints apply to. Like I said, this is the master list of every constraint. If I just look at this particular part, which is the piston itself, here are the mates that are associated with the piston itself. Right there. There's three of them. This is helpful to track down what you've done, especially if you've locked something down, you can't get it to move the way you want it to move. It's probably a constraint that needs deleted, which you can just come over here and say delete. I just right clicked on my constraint and delete it here. So you can show them here too, like on this tab here, like just where I pick my constraints. If you pick to show them, I thought they all showed up. Why the heck? I thought they would all show up. They should show up as little symbols. Hide all. Oh yeah, I got you. So if I click show and then I click this, yeah, there we go, there we go. You're good, thank you. Yeah, exactly. And they kind of, I view them as the same as the constraints from a sketch, right? Like they are kind of geometric constraints in a way. And so, and you can delete them from here too. If you can show them, highlight them, you can delete them from here. I'm pretty sure if I right click this thing, I have the option to delete it, suppress it. Suppress just means it's still there, but it doesn't function for me, right? It turns it off so I can move it. That's one way if you've applied a lot of constraints, you can just choose to suppress one or two here and find out how to free up the motion you're looking for in an assembly and how the parts work together. So, and then you can just hide all here, right? I think hide, yeah. Yeah, so that's kind of handy. I feel like I use them more from here, from the model browser than I do just like having them show, but that is healthy. I have had to troubleshoot some yeah, some parts that are constrained and difficult to figure out what's going on. So what's that? Oh, I just hit the hide all? Hide all? Yeah, so yeah, exactly. You guys hit show. There's my, and then if I just hit hide all, they pop off. Yeah. Well, so that's that. What else is the next one? I think we have to put in the little crankshaft, maybe. Yeah, I mean, we still have some movement that needs to be locked down, so I can't say I love everything yet, because mostly that my piston can twist here, but I think this is going to help us fix this twist that can still happen. Ideally, this my piston in cannot do that. It needs to stay probably in this linear alignment, and so we're gonna lock this down so it can't twist. Other than that, we're pretty well constrained. It feels like a little more movable now. Things don't blow up on me when I try to move them, and my parts don't go flying out here now. So it's still that little arm can still move, but it does have a lot more control based off those last couple of constraints. So, okay, cool. It's getting ready to go in there. This little thing needs this our last little part, right? We gotta put it in where it goes. I think this thing is symmetrical in a way too. Like I think I extruded these both the same. Yeah, I did. So I don't feel like it matters which one I choose here. Right now, these are both the same. And so I'm going to which one does it apply first? I think it hooks one of these to this hole here. So I'm going to use the same mate type constraint that's this axis here of that feature. Really, there's an axis. These are uh, concentric axis. Whether I choose that or that, it's about the same. I'm going to choose this specifically because that is the part of that that is going to insert into here like that. If it didn't go the right way, I could spin it this way and be on the other side, right? That's a simple fix. If I need it, I think I do need it to be the way this way here. And I think that's
Wait, do that one more time, please.
which way did I do? What did I do? I think I just did this constraint to here, this little, I chose this rather than this, even though they are the same. I chose this. That's the specific part. You could have picked either part though, I feel like. That is a symmetrical part, and I'll put it in here. Yeah, those two. And what's the next one it wants me to do? I don't know. It had me do what's that? It wants to be on this side because technically I think they've set us up to do like a modified part anyway, because technically this one is going to need to align with this hole here. So it really needs to be oriented this way so that this one will be in this hole and this one will be in that hole. I think we have to do a little length adjustment on this to get it to go through that hole. I think they did that on purpose though. Well, for one, it makes it easy at this stage because they're like, it doesn't matter which one you assemble first. Now you got to pay attention to which one you want to extend potentially. And so, yeah, and so I was just looking ahead to see what other constraint they're adding here, but I think just um, what else does he do? Yeah, I think they do that one. I'll say apply that one. And then if I just turn this off for just a minute, the next one we do is I think we take the end of this surface and made it to the flush with this surface, so that this thing will be flush in here like this. So this one currently can slide either side of that, and it can slide this way as well. Sorry, if I could flip it up, it could slide that way, but really I'm just going to mate those two together. I think it's just like a mate type constraint here. So that surface here to this surface here. And that solution doesn't necessarily pop together. So if I do the other one, it does. I didn't get my click, but I think this is okay if I hit okay or apply. Yeah, it's a legit constraint. And now this thing is ready for this thing to be constrained in that hole if I can get it. Kind of. So those two are flush. I see that. And the last, it's probably really close to some of the last constraints here. Yeah, they just show you. They kind of set you up to do to learn to edit, modify parts while in the assembly panel. Yeah, I don't know what speech is going on there right now. So I think. Oh, they show me that I think the connection rod itself is too short. Let me just check something real quick. Do they try to align? I may have missed the constraint. I don't know. Do they try to align? Yeah, I think the first one they did was different than the first one I did. I think I think they also, the first constraint they would have done with this was maybe hook this one into this one, which I can still do that. And I'll say okay on this. See that all that is like these two are now their axes are now aligned. That yeah, the axes are yep. So that last one I did was this probably from this one right here. Those two. Of course, those need to come together. So that's one problem we have. I think the other problem that it shows is that and they've just done this so you have to edit this exactly, is that what this is going to do is this thing is going to rotate around like this, if I can grab this part maybe and rotate it. We want our part to be able to slide in and out of that. And it really should slide in all the way, not through this backside, but it should slide all the way and make this volume of this cylinder a lot less. So this is not, what they're showing is that this is not sufficiently like going into my piston case far enough. So I've got an issue where this connection rod is too short. They pre-planned it to be too short. So it just needs, like in my book, I think it says, oh, we need to extend that thing four and from two and a quarter was our original hole to hole center on the part. They say, after evaluation or whatever, they need to put it out at 4 3/4 long. So what they're doing is they're showing you can edit that within this assembly. So if this is where you notice that problem, we can say, oh, this part needs edited. So I think I can double click on that. It'll go into this edit mode actually.
Uh, the part, like those.
You just did a double click and it took you to the part. Could be that. Yeah. Do I have it open? Yeah. Let's test that. I think mine just goes to the menu. There's another way to go here though, which is just select it, right click and have edit right here. So you don't even have to have it open. I can just technically I just have my assembly. I haven't even saved my assembly yet. It'll make me save it before I try to put it on a drawing though. Like it won't even let me put this on a drawing until I have it saved. But yeah, so that's one way. If yours isn't good, if you don't double click and go to this edit mode and have your ribbon menu change, that's okay. If you can also just like left click it once, right click and hit edit, and it will go to the same menu that mine's double clicking to.
What if mine?
Is your edit grayed out?
Yeah.
It won't allow you to change that, huh? This is not allowed. Yeah, maybe close. It wants you to close the part before you edit. That could be true. Oh yeah. So if you have this open, that makes sense to me. I can kind of remember that. I have my part open now. Edit's not available because I have the part open. So yeah, close your part. And now edit's available.
Like you might as well just go to the part and fix it.
Yeah, for sure. There are times when I do edit this way, but I don't always edit this way for sure. And so the other thing to notice is when I do this, when we're actually going to edit this part in the assembly, is it kind of gives you access to that part down here, and everything else is grayed out on the. If you notice, your model browser kind of grays everything out, and then what's highlighted or what's normal is actually that part and the steps that are associated with that part. Really, it goes back into where you're kind of into the original part. So here's the original sketch, right? This is what we need to edit. So I don't have mine turned on. It's not visible, but I can highlight it just by expanding through its menu because that's my only thing that's turned on or the only thing that I'm editing here. And so really I expand my extrusion here. I'm way down on my left, and then I am going to edit this sketch right here. So I'm just going to right click and say edit sketch. And I can get in here and change it. There's my nicely constrained sketch. Hopefully yours is too, not purple. And I'm going to say, oh, this should be 4 3/4. And really what this is going to do is all the constraints that are in the assembly are going to maintain. Like it's going to like push everything out, keep those axes aligned, and it went the wrong way.
Yeah.
Yeah, I just finished my sketch. Yep. I just did my one data input, finished my sketch, bam, it just kind of blew up. Change, and then I'm still within the edit mode. So I think you can right click and say finish edit, or up here on this return is like return to the assembly here. And I think it closes down the edit mode here. So either one, you like right click and finish, or you can say return up here. and then it's going to make those jumps. You'll get some errors if it conflicted, if your constraints did conflict with how that part grew, if you had something locked down. Like really, if I had a dimensional constraint between something here and that, and it wasn't going to allow that part to grow, you'd get errors with those constraints, and they show up as exclamation points on your constraints, and they have to like be reconstrained. They're editable, like I said, your constraints are editable, just like a feature. If I go in here and say I want to edit this, it brings up the dialog box. It brings up everything that's associated with that constraint. It allows me to edit it. It's not that I have to go deleting all those constraints. Usually, I just need to maybe potentially rework them, and maybe I find that some were my initial constraints that I chose were not good if I'm going to change the part length. So I mean they've set us up to where this works good. And then I can spin this thing here. And now my piston actually stays in the cylinder, and it doesn't come all the way out, which is critical on a piston, and it doesn't go all the way to the back side as well, which is also critical. So technically they probably, yeah, that was the right adjustment on this particular size. And you can see that, oh yeah, I think, do I have to do another edit though? So that's that edit. Yeah, I think I have to edit the little pin on this. So it wants me, it wants this pin to be extruded actually 2 inches instead of the 1/4 inch that it is. So I can do the same edit here. Just right click, say edit. I'm into this thing. It's all of its features now. It was a little more complicated part, right? We had this extrusion, which is that sketch. We had this extrusion, which is the one I need to change, and we had this extrusion, which I don't need to change. So I really have to find out which feature I'm actually wanting to edit. It's this sketch here. It's actually this extrusion. The sketch is fine. The sketch is just the circle. It's the extrusion length that's incorrect. So I'm just going to right click this and say edit this feature and make it longer, right? It should be a 2 inch instead of a 1/4 inch. I need a measure. Yeah. So yeah, exactly right. If you're in here and I'm in this extrusion and I'm going to edit this feature, always right here, this little arrow next to your dimension, like this is how we originally built the part. We entered 0.25 in here. If whenever you have a data box that is that you can enter a dimension into, there's always this little box next to it where you can actually select measure. So if you didn't know, if you're like, oh yeah, I don't know how long this is, but I want it to extend, and then I'm just measuring from like this face to this face, it'll be like, okay, that's 1.5 inches. And it will apply that dimension between those two. And I'm like, oh, that wasn't quite right. It's that plus, actually, I want it to be that plus 0.25. That's actually a legit dimension too. Like I have what I need plus a little bit added for something. Um, Sometimes this is the way I add tolerances into my part. Like I might have the kind of the basic size as my dimension that I'm using, and then I might enter a tolerance in here. Um, and then when I go into this dimension, I can see, oh, there's my tolerance I've applied here or something. So I do that strategically. I wouldn't necessarily want to look at the dimension with like it'll look like that if, but if I click in the box, I'll see that it's an equation or something. We'll talk about that when we do our modification. But this one is, I think it's supposed to be 2 inches, right? 2 inch. They want it to stick through a little ways, so I'm gonna say okay. I think like this, yeah. And then we can either return here or we can say finish edit and it goes back to normal mode that way. What's that? I just did it like the book said, 2 inches. Yeah.
That's what that's the feature. I wasn't sure if it would still be it while in shadow.
Yeah, there's one more. We have one more little constraint to do, and then we're almost done with our 7 here. We have like just a couple little things to catch here. So, oh yeah. I don't know why. Maybe this is so I can grab it and spin it. It's like on my fidget widget, which is what I call this thing. And I only call that because when people come in here, like I heard Rob last week say, you guys draw widgets over there. I'm like, yeah, we do. So we're gonna draw a fidget widget, and we all like a fidget toy. So I just when I did mine, I put my little handle over here to like twist my. But you could put a handle over here too. I do need to have this bore go through here though for stability for it to turn here, and so I feel like this design could be changed in a lot of different ways actually. But and we do some modifications. The last constraint they want us to do is an angular constraint, and they like I am spinning this thing right here, like I'm showing that this is where this is spinning, And what they do is they apply a constraint, an angular one from this surface to this surface on that, and they hold it at 0, which will lock it down to where it doesn't move. But I'll show you why they do this here. They're going to kind of animate this thing. And it's just kind of a low down and dirty animation here. But we're going to do another constraint. Instead of doing a mate type, we're going to do an angular type. So I'm going to select that. The solutions look a little bit different, and usually, and generally, and I may have, in some cases, I may have 3 selections that I need. In this case, it wants me to pick like this face and this face here. And at 0 degrees, and I think it wants me to have, I don't think this is my correct solution here. I think I need this solution here. There it goes. I just saw it move into, I didn't hear the snap, but I did see it move like it. Generally, I'll know that I'm on the wrong solution if I don't see those things like go into kind of the alignment that I'm expecting, and then I will choose a different solution. So just my default was up on that last selection, and it wasn't the correct one. This one might still be okay. I could have selected probably either of these, and it's okay. It's kind of just the same way. It's either that way or the other way. And then I think we just kept it at 0 and we hit apply, or this is okay. I can close this now. What that one did though is now I can't turn this anymore because that was like these are now have to maintain 0 degrees between each other. So 0 degrees between each other. And so that's great. And this is what they do last is they just animate that particular constraint. So how we do that is you find that constraint in your model browser, which is the last one I just did. You can either find it from your relationships and all the way down, or you could find it as, if I select this part and you go down through its constraints, they'll be the same. It's, I don't know, is it flush? Not that flush. Is there another one? Oh, maybe I'm looking at the wrong. It's that part. Oh, this one, that one, angle right there. Yes. They share the same name from this list. But what we want to do is if I actually right click that, like I was going to go to delete it, but below it is a drive. So I'm actually going to drive this constraint. So then I click drive and it brings up this dialog box that says, oh, you want to start on 0 degrees. That's kind of how I have it constrained. You want it to end on 10 degrees. I think these were default selections that were put in there. I'm going to say, no, I want it to end on 360 degrees. I think we say 360 degrees here. So I want this, and what I'm going to do is drive that constraint from be 0 to 360, which is going to make 1 revolution. And then am I going to pause and delay? No, I'm just going to keep this at 0. And I think I just hit play on this thing. And this thing will drive.
Witchcraft.
It is witchcraft. It is cool, actually. It's really cool. And then I think I can go the other way, or I don't know. Do I just play it again? Play the other direction? Yeah, I think it's directional. So it's like I'm going to rotate this way, or I'm going to rotate the other way. Oh, this is my faster, you're saying? What's that? Fun size and print. Yeah, we are going to print one of these. Yeah. Actually, yeah, see, I have, correct. The other thing it can do here,
Because we made it, that's why.
yeah, the only reason why that moves is because there's no conflicting constraints. There's no conflicting constraints here that don't allow it to move, right? Like I'm actually only driving that one constraint. But if you had constraints that don't allow that movement, it won't, they won't animate that way. You have to delete constraints. So really they used very minimal constraints to do this. Yeah.
You can change the degree from 360 to like 360 million or something.
Yeah. Or like this. If you expand this down, we can actually this is kind of like an expanded list here. I hate that they bury these like that. I wish this whole dialog box just opened up, but watch this in dialog boxes for like an expandable menu. And here's where you can say drive it more times, right? So what did this actually opened up that the repetitions here, I guess. I could say so you could say just 360, but you could say, oh, let's do this 4 times. And then if I drive this, I think it'll do those it'll do that same movement and it'll just do it 4 times. Yeah, so this is your car engine, right? So this is just like your crankshaft does this. What you're doing is you're injecting fuel and air into this cylinder here, and this is where the piston compresses that fuel air mix, and then a spark plug initiates a spark that ignites that fuel air mixture in that piston and it causes it's a controlled explosion, boom, and it forces that piston back down. And so that's why I don't know if you've ever seen an airplane or whatever, and they go out there and they twist it, start it, right? The explosions itself will keep the engine going, right? Pop, 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 like this, the blast blasts the piston back down. And anyway, it's a little more complicated than this, but this is essentially how your controlled explosion of your car is on one of your cylinders. So this is just a single cylinder. Like I drive these little Honda 110 motorcycles. They are just single cylinder driven. They have about 5 horsepower and top speed 35 miles an hour. And just total junk. They're the Volkswagen Beetle of a motorcycle. I love them. And I have 7 of the stupid things. That's how much I love them. Yeah. I have 3 parts bikes. Wait, if I do have a YouTube channel. I'll never let you know what it is, but no, I have an old YouTube channel where I do ride my 110s on the desert and my trail 90s.
Start showering.
They're not too interesting actually. It was me being bored during the pandemic is what it was.
No, yeah.
So then I can record this though, right? Like so this little record button will record this animation and I think it'll make just a like a Windows Media Player file. So if I just hit record this, I don't even think it notice. I don't think you really. So I have it as 4 revolutions. And so if I hit record, it wants to know where you want to save this, where you want to save this file. So I'm gonna find where I want to save this, which I'm just gonna save my animation in my week 3. It's gonna just look like a Windows Media Player file. Yeah, WMV, Windows Media video file, maybe WMV file. Um, I called mine like an animation. You can call it whatever. Like I just save it in my file next to my parts and my stuff. So mine is animation. I'm gonna call mine chapter 7. Yeah, you can call it whatever. It just needs a file name. Save it. It gives you some. I think I'm just going to leave the defaults here. It does you allow to custom some of the image size. Maybe it does help the resolution be better, but I think you'll notice it's kind of a crappy resolution when we do this here. So maybe I could modify that, but I just hit OK on these default settings. I think just give it like 30 seconds here. It is saving the file. It's actually like playing this back or just saving it. I think maybe it takes a few minutes. Not a few minutes. I think it takes 10 to 20 seconds maybe. Then you should be able to find that file. So I'm going to go to my file browser. Yeah, I guess if you go to open that file too soon, and maybe it wouldn't have finished saving itself, so you can get like just a partial view. So yeah, I've given mine a good 15, 20 seconds. I'm gonna go find it here in week 3. So here's my animation. Here's my file. If I open that thing up, it's opening over here. And then I just hit play. Maybe. Maybe my file didn't save yet. Mine is a pretty slow, and it's 4 revolutions. So I think mine has not saved yet. I'm gonna go back again and do it again. Maybe I'll cut this down to, I don't know, 2 revolutions.
You have to click play for it to start recording.
Yeah.
Oh,
Oh, I do. Oh, yeah, yeah. Good, good. So I do want my 4 revolutions. Thanks, Riley. I forgot. Yes. Let's hit play. So let's hit my record. Uh,
Or the audio. Everyone cheering.
maybe. We'll have to see. I have my mic turned on, so
So if you
Yeah.
pull an audio and play it.
there might be an audio input in Inventor.
The new sound effect. The new sound effect for command.
no big sound, right? Like, so-
I know.
Click, like that click.
I know.
You're like, yeah.
Yeah, yeah, it's true.
Guys activating it.
Yeah, you're right. You have to hit record and then it has to go gray. You have to hit play and do that. Correct. Now my file should be a little more correct
My
here.
video is 2 hours long. It's 4 revolutions.
Oh, it's terrible, but it's mine.
Oh, and I opened mine too soon. I don't think it had finished saving good. Yeah, I'm gonna go backwards here. Yeah. I think after it finishes recording, you need to give it that 15 to 30 seconds or something
Going on.
to create the file.
Oh, no, it created this.
Oh, cool.
The video itself.
Quality's so bad.
I don't know. Speed up the video. Yeah. Yeah.
And try again. A little bit better at.
Way better.
I didn't think a little bit. I feel like I'm on LSD, because it's like.
Just the swirly nature of that. Yeah, I agree.
It still looks so crappy. This looks like it was.
I gotta resave mine. Why is Jack and that?
Chalk. Oh.
How come when you play forward, you play that?
I don't know. That's kind of funny. It doesn't go back.
Itself or something?
It's like a VHS tape.
Yeah. What?
Is my child.
Oh, yeah. It is a VHS tape. Like,
It's totally-
tape. You have to rewind it.
You can hit the like all the way to the beginning and just jump them.
It's just funny that
Collision
that's the
detection?
standard.
I don't
default,
Okay, 5 is not enough, maybe I'll try 10 this time. Try 100. Not too bad.
No.
You try.
Do 360.
It
And one thing.
doesn't make its movie.
It is true, and what's funny to me is that that's like it's what your manufacturers will want. You know, when it was pretty routine in our drafting and engineering department at the food processing place I worked at that you'd have customers walk through and they'd be like, "Oh, here's your piece of equipment we're modeling right now. Go ahead and like show it, bring it up." And then sometimes we'd show them animations with it, and that's what people want to see these days. They want to see the house and walk through it before they ever build it. So customers are expecting to have those renderings and those animations. And then they also, like in the mechanical world, people want to see the parts. They want to see how the design works. They want to analyze it here. And so as the programs get more complicated, our output, people want to see that as part of just the delivery of our designs, whether it's to talk about it and discuss them and refine designs or to show customers what they're getting. It's just is the nature of it anymore. So it's the name of the game is to be able to be good with the software. And I caught Rob saying that several times last week. He didn't focus on your drafting skills need to be the best. You need to know all codes memorized. He's like, you need to be good with the software. Because that's why, your guys' role will be taking legacy AutoCAD garbage and turning it into art that can be animated and can be more interactive. Yeah, so that's good. So really, these legacy Idaho State University in general need to get with the program and update all their CAD files into Revit files. I mean, it's going to take forever. So job security. It's good.
And people that get retired.
But you got to have people retire first. You got to have managers that want to make that change and realize that the time invested in it is worth it. Yeah. There's some give and take there for sure. That's the end of this part, though. That is the end of this part. So I'm gonna stop my. Yeah, I guess I never opened up my filing. I think I did finally get mine recorded correct, but let me just check it. You guys are already done. I'm the one that's struggling here. Oh, finally. I mean, it's like slower than a slow. Mine is on default 1 degree. Yep.
You want to turn our video in?
Oh no, you don't have to turn the video. No. Yeah.
Might be able to work.
Yeah.
I put mine at 100 speed.
Oh, that's cool. It's like a real car. Yeah.
The act doesn't jump.
Just
Yeah.
359
Yeah, put it on the video.
degrees.
59. Then it.
Oh, yeah.
Probably backward, wouldn't it?
Before I do pull off of here, one thing that I like when I have an assembly like this and I need to analyze, like we know that this thing will not actually work. I mean, that is a size on size piston in it. That is not going to be good. Really, a piston has rings on it, and there's like these special parts that go around a piston to actually make the seal, like metal on metal seal. Uh, and so it's definitely like a very simplified version of what's going on. The other thing is it's size on size. So we would have issues with this fitting inside that, and we'd have issues with all of this being able to fit together. How you can check that kind of stuff. So in my assembly, the way I check that is I use my view tab. On my view tab over here on visibility, which is really cool. Actually, if a couple things I point out, here's like the center of gravity. If you click this on, update it now, okay. It actually shows you where the center of gravity on this thing is. Can be helpful for people if this is a very large assembly, how to know how to pick this thing, and maybe where I would design pick points on a really heavy object. I need to maybe know where the center of gravity is. I can turn that off for a minute, but half section view is what I use a lot when I'm checking tolerances and I'm checking fits. So this little thing, so I'm on just the view tab, half section view. So if and I can take a quarter section or a 3/4 section, I use half section view a lot, and I select this, and then it's just like, we'll pick a face to start your section, your view section at. So if I wanted to take a look at maybe how the cylinder was fitting in here, I mean, I can get a pretty good look here. I can see it internally if I select here, and then it just says, I have like this gold arrow here. What I could put in a dimension to offset this, but I can actually just like click and drag and pull my view through here. So now I can I'm taking kind of a section view and seeing how parts are fitting. Like I don't love the alignment here of that wrist pin. To me, I use the dimension they gave me. Maybe I'm using the dimension they gave me from an opposite face. So I can tell here that the dimensions that I've used for my wrist pin, while they look like they're good, when I look at them at section, I'm definitely not centered. And so it could be that I'm using the wrong face selection with that dimension. And I don't know though. I don't know why that's technically, I'd have to kind of troubleshoot my constraints a little bit to see if I've got that centered. Ideally, this part should be centered in the piston, the little parts that hold it. But I get an idea that, oh yeah, look, I mean, like this is going to be size on size. There's no tolerance applied. There's very small likelihood that these parts would actually fit together, especially, if you're going to 3D print them, and there's going to be some inaccuracy of how accurate the 3D printer can make the part. And so this is probably not likely going to fit together actually without some tolerance applied. So, but you can cut down through here and take a look at maybe how these parts are fitting together even further. You can save this, I can hit check and it'll save like that. Like here's like that view. I come in here sometimes and I'll use them for a minute and then I'll like delete them. Yes, delete them. So I might just delete that view. Half section view. No, I don't want to. I just deleted my current one. Escape here. Oh, sorry. We cut it this way. You can take a look this way. So I do a lot of analysis on my parts, especially when I'm at the assembly mode. Make sure things are fitting how I want them to, and delete section views where I can go to get rid of that section view momentarily. So I like that it'll hold it because there might be a place where I want to hold that section view for a while, go back to the parts, maybe make some adjustments, come back and see how they work. Like this video is a little bit long. I know I've been recording the whole time, but I'm going to do one last little thing. So what I've recognized is I don't love in mine the placement of this part, this wrist pin in that. It is locked down. I can't move it because I do have if I expand the constraints here. By the way, you get used to over here, you expand all these out, they get a little bit of annoying. If you just right click in no man's land here, or yeah, you can say just collapse all these. So there's my parts in their simplest form. I like to have my origin planes on, but really I'm looking for the constraints that are associated with this part. And it's probably this part that's causing my problem, actually. Like this isn't allowing that to be centered. Whether I reverse it or not, I don't know. Or choose the other side, I don't know. I didn't love this way to constrain anyway. And the reason why is because of that a little bit. Like what I've got going on is one of the reasons why I don't like that dimensional constraint there. It didn't align me up centered. And it could be just me picking the wrong surface. But how I would have constrained something like that, based off some experience that I have, is from like it's origin planes. I love origin planes. Like this part here has these origin planes. There's that one, and there's this one. That one doesn't really help me much. But if I build my parts correctly with the origin planes, maybe where I really want them, they can be really handy for constraints. So this is why I've talked about it in the last couple times we built parts. I've said sometimes I like my origin planes to be centered in my part, and then I will use them in the assembly for constraints. Because if you constrain things to their origin planes, there's no dimensional things happening. It's kind of like an axis in a way, only it's a plane. And it'll, to me, I love it because it allows me to like center stuff onto each other centered easier than some dimension. And then when my dimensions change, and you know me, like dimensions might change, then my planes never change. They're like the center of my part. So they're really good ways. I use my center planes to constrain a lot. So in this case, like how I would maybe do a modification to have this issue, and the issue that I'm solving is this, which you may or may not have. I don't know. I'll go back to that my view here. So I'll show you that I'm going to fix. What I'm going to fix is this. I don't love this. I'm going to keep this here for a minute. I'm going to select this. I don't love that this isn't centered. So I'm going to fix a couple things on my parts. And I'm going to say, oh, you know what I don't like is I don't love that one. I don't love this constraint. So I'm going to delete it. I'm just going to delete it, which allows this part to move now back and forth. And I don't love how this part is designed. I don't love that this is like an axis that I mean, I like this plane on it. I like this plane on it. I don't like that my part is not centered on this plane. And if it was, I could use this center plane and potentially if I had my plane on this one. So let me check the origin planes off this part. They are like here, here, and then I extruded that thing off center that way. But if I would have done a symmetrical like extrusion across the center plane, I could really hook the center plane of this into the center plane of that instead of using a dimension. So I'm going to do that. I'm going to go back into this part. And here's how I probably wouldn't edit that through here. I'd do like my open and go back into the part. And here's my part. And here's my extrusion. And then I'm going to edit this feature. You don't have to do this. I'm just showing you how I would do this. This is how I chose to extrude. It was from that plane that way. Well, what if I said, no, I want it to be like this? Now I have a center plane. I have this origin plane that'll be centered on my part. I'm going to say, okay. It doesn't really change the part much. It just kind of changes the relationship in model space of how the planes are working. And then when I go back here to this, I get those little lightning bolts, like something needs updated. If you just click on this one on your quick access toolbar, bam, that like kind of moved around because the geometry has changed a little bit. And now when I select over this, I have this centered plane here. Now I'm going to change this part as well. I'm going to say this part, I'm going to open it. And I don't love how this is extruded from one end here. So I'm going to edit this feature. There's how I originally extruded it. I'm going to split over center line here. I'm going to say okay. And I'm going to have a center plane there as well. Now I'm going to go back and constrain those two center planes together. And this should help my alignment issue that I have in my part. So I'm going to go back to my assembly. I'm going to go ahead and update that. It's changed some things here. It doesn't know where. I think I'm going to check my constraints on this part. It's just really just a mate there. That didn't change anything. That's good. And it has this mate here, which is good. I want those two to stay alive. So I'm going to keep those two. I'm just going to add one more constraint. So I'm going to say, okay, assemble, constrain. I'm going to pick those planes. So I have them expanded down here so that I can select them. So I'm looking at, I have to have them expanded so I can get them, or I can turn them on. But even without turning them on, I just have them expanded so I can get to them. Here's this plane. I'm going to constrain that plane to this plane right here. And then that thing snaps together. I'm going to say, okay. And I'm going to check my alignment. I don't have an alignment issue now. So that would be how I would prefer to do that and not use some weird dimension. Like I never want those to I always want their center lines to be constrained together. Well, what I fixed was how I extruded here. So however you've extruded this part, I chose to extrude centered over the plane, symmetric from my sketch. I'm symmetric to each side of my sketch rather than pushed to one side or the other. I'm centered, which really is this. So, that's all I've done. And then that puts my sketch, for one, it puts it on that center plane right here. But really, I'm looking for that plane to plane alignment. I guess the end of my story here is, and this is, not in the book, but um, I can't over express how critical your origin, planes, axis, and geometry is. It comes preloaded with the part. It's smart to use it. Just be aware of it. You're not just creating random parts, but you're creating parts that are going to work with each other, and having them design somewhat thoughtful will help you with their how to align them, right? And this will help me in the event that I make a 4-inch cylinder. I have a really good base to start with here. If everything is dimensionally constrained, it gets really annoying to modify this to a 4-inch size. But if I have like minimal dimensions put in, more geometric constraints, then I can make changes faster to this whole assembly and not have to go back in and fine tune every little dimension that I put in. So just think, always pause for a minute and be like, should this be a dimension or should this be a geometric? And if you just cause yourself to pause, it's going to take a little while to build that, but eventually you'll learn that you're going to be putting more geometric type constraints, whether it's in your sketching and the part or even in the constraining and assembly. I feel like the good designer, yeah, I feel like the better designer is going to use more geometric type constraints than dimensional. And the good designer might use more dimensions, but and it's going to be hard to balance that. Sometimes it takes building something multiple times to be able to decide like, here's my minimum data inputs that I can design a part by. But that is how a person changes from a drafter fixing red lines to a designer that an engineer can trust a little bit. So yes, let's call this one.